This is lesson 6.1 and 6.2. Just to kind of remind us, the first part here is talking about the normal distribution, and we're going to go into this further detail in a minute. But remember, in order for it to be the standard normal distribution, it has to be a bell-shaped curve. Our mean, which is mu, has to equal 0, so the mean has to be 0. And the standard deviations has to equal 1, right? There has to be one deviation between each of the lines on the graph. So that's a standard normal distribution. Before we get into that too far though, we're going to talk about uniform distribution. With uniform distribution, the area underneath the graph has to equal 1. So if you were to solve for the area, it's going to be a rectangular shape. The area has to equal 1. Because the area is equal to 1, there's a correlation between the area and probability. And so some of the probability can be found by corresponding area within the graph. So here's, density curve. Let me talk about density curve really fast. Density curve is kind of the same idea. It's what's going on underneath your uniform distribution. The area has to equal 1. And the curve has a vertical height of 0 or greater. I'll show you what this all means in just a second. We'll call this 1 and 2. That's what density curve shows us. So, New York City subway during the weekday in the late afternoon from Times Square to Met Stadium, the number 7 train leaves Times Square every 5 minutes. The waiting time, which is going to be represented by X, is between 0 and 5 minutes. Waiting times can be any value. So in other words, you can have 2.33457 minutes of waiting. So any value between 0 and 5 minutes is your wait time. So let's look at a uniform graph here, or our density curve. What we have here is, I'm going to just draw this here. Here we have 0, and 0.2 is at the top. That's a probability. Okay, so this is probability, so P of X is our vertical height. Right here it says vertical height has to be between 0, or it has to be 0 or greater, so 0 or greater, that fits that rule. Okay? Next, here we have wait times. We'll say 1 minute, 2 minutes, 3 minutes, 4 minutes, and 5 minutes. This creates here a rectangular box. The area of this, if you were to take length times, length times width, if you want to think of it that way, 5 times 0.2 is 1. And so that means the area equals 1. The wait time can be anywhere within that segment, okay? So there's that probability that corresponds between area and the probability. Now, let's say we want to find the probability. I'm going to write this down so we can discuss what it means. That means the probability of our wait time being greater than 2 minutes. Okay? So, kind of what we're looking for here, guys, is we want the area, everything greater than 2 minutes is right here, right? So we just want to find that area. Well, how much is the length here? This is 1, 2, 3, so the length is 3. And we're going to multiply that by the height, which is 0.2. And the answer we get here is 0.6. So there's a 60% chance that you're going to have a 2 to 5 minute waiting period. That's how that curve works. I found the area, but the area ended up being my probability because the height is probability. All right, so there's uniform distribution with the density curve. Now, back to standard normal distribution. You're going to remember that with our bell curve, of course I don't draw it nicely. I mean, you could put eyes here and a nose and it would look like the old wavy hairstyles, right? Never mind. Okay, going on. Anyway, the area underneath all of this curve is also equal to 1. And you'll remember that there are 3 deviations, right? Our mean is 0, +1, +2 deviations, +3 deviations. Each of those lines represents a deviation, okay? From the mean. Okay, hopefully that looks a little bit familiar to you. What these bottom numbers represent is what we call the z-score. Okay? The z-score is the number of deviations away from the mean. So it could be 1 deviation, 2 deviations, it can be 1.3 deviations away from the mean, but that's what the bottom represents, is the z-score. Now guys, there's a table that we're going to use to help us solve these, okay? You can use technology, and technology is going to be more accurate, but unfortunately it's difficult for me to show that to you, so I will do my best to at least show you the book and how to use the table. Okay? So, let me show you the table really fast. I'm going to move you. Right here on page 584 and 585, I'm going to zoom out. Sorry, it's on the dresser here. So, 585. We have 2 pages here. We have the negative side on the left and the positive side on the right. Okay? And what these are the z-scores. And the left-hand side over here, this gives you the first points of your z-score. So negative 3.4. The top up here gives you the hundredths place. So if I had negative 3.45, I would choose negative 3.4 line and follow it over to where I get to 0.5. The probability of that happening is 0.003. Okay? That's the same for most of these positive values. If I had 2.13, I would find over here on the left hand side, sorry, this is the right page, but on the left hand side, 2.1, and then this is 2.11, 2.12, 2.13. So you would have a 0.9830 probability of that happening using that z-score. So the z-score basically helps us figure out how to find the probabilities. Now guys, there are some special rules here. You'll see this right here. I follow that arrow down and it tells me the value there is probability of 0.05 for negative 1.645. So there are those special markings. There's some over here as well on the positive side. You can follow those over and it will tell you their values, okay? So those are in-betweeners, okay? If you ever get in-between numbers, what you can basically do is you add the 2 numbers together and divide by 2 if you ever get 2 numbers, okay? Alright, I'm almost set back up here. This is kind of funky. Apologize about that. Okay, now that's how we look at the tables. Now, a bone density test has a z-score of 1.27. Find the probability that the result is less than 1.27. Now guys, when we're using the table, we are, let me draw this up here. Keeping this in mind, it was 1.27, so here's the mean, here's 1 deviation, here's 2 deviations. 1.27 would be somewhere around here, right? So that means I'm 1 full deviation away and 0.27 towards the next one. Now, when I find the probability using that table, what that is just finding the probability of everything up to that point from left to right. It's not giving me the probability to the right of those points. Okay, so no matter what, whenever we use the z-score, it always gives you the probability from left to right until you hit that point. Okay? So, when it says that you want the probability of less than 1.27, basically I just have to find 1.27 in my chart, and then that will be my probability of everything less than 1.27. Okay, so what you're going to look for is positive 1.2 on the left-hand column, and on the top you're going to find 0.07, and you're going to go to where those meet on your table, and you're going to find the answer is 0.8980. That's an 89.8% probability. Okay? That's what that is. Alright. Everyone okay with that? Make sure you find that so that you know what's going on. That's everything to the less than 1.27. Okay. Now, find the probability of results above -1. Alright, so let's kind of talk about what that's explaining. Find the probability of everything above -1. So, here we go. On our bell curve, here's the mean. This would be -1 over. So basically, when I find this, I'm finding the probability of everything till that point. But I want everything above it. This is actually what I'm looking for, everything up here. So the way I'm going to find that is I'm going to find the probability of -1, and then I'm going to subtract it from 1, because I'm basically finding it's complementary, or it's opposite. Now in the book, on the left-hand column, you're going to find -1.0, and then on the top you're just going to look for 0.00, which is the first column. That value that you should get when you look for that will be 0.1587. Now guys, that's not my answer. That's the probability right here. 0.1587 is the probability of this area there, not the probability of everything greater. So we're going to take 1 minus 0.1587, and when we solve that, the answer that we're going to get is 0.8413. That's the probability of everything greater than -1 standard deviations, or -1 z-score. Now, let's get a little bit more tricky. We want to find the probability of everything between -1 and -2.5. Okay, so we're going to find the value between those. In other words, guys, on our bell curve, -1 would be here, and -2.5, this would be -2, -3, so -2.5 would be right here. So I want the area of just that little section. So here's what I already know. I already know -0.1 is this answer right here, right? So that's the full area all the way to -1. Now I want to find the area from left to right to this point, because if I subtract them, that'll give me the area in between. So we're looking for -2.5. You're going to find -2.5 on the left column, and then 0.00 on the top column, where those meet. Those meet at 0.0062. That means that's the probability of from here to right there. That's it. It's 0.0062. We want in between these two. So we're going to subtract 0.1587 minus 0.0062, and that area in between them is 0.1525. And that's it. That's the area in between 2 points. Now let me show you some notation on how you're going to see some of these problems explained. Okay? I'm going to explain them to you. If you see this, then that means we're looking for the z-score in between the values of A and B. That's exactly what we were just doing. That would be the probability of -1 and -2.5. Actually, I do those backwards. -1's bigger, so -2.5 and -1. Okay? That's the one we just solved. That means you're finding the value in between the two. You're going to subtract the probability when you find -1. That's a -1 z-score. You find the probability of it. And the probability of this one, you're going to subtract those in that case. Okay? So that's the first way that you'll see problems. Another way is when z is greater than A. In other words, we're going to find the probability of everything greater than that. That's when you're going to have to find, you're going to have to do the 1 minus the probability of A. Okay? It's really hard to write that in notation, but you're going to do 1 minus whatever the probability of A is, because the probability of A is everything less than A, and we need to find out what everything greater than A would be. The next one is find the z-score, the probability when the z-score is less than A. That is basically when you use the z-score to find the probability, that's your answer. And so that one is just, you don't have anything special to do afterwards. Right, moving on. Finding z-score for known areas. Now guys, in this case we're going backwards. We're going to know the probability and we want to find the z-score. So let's say we want to find P of 95. Alright, so that's the 95th percentile, which means the area is 0.95. Right? So we want to find out where that's at in the book. I'm going to do my best to try and show you this. So what I need to do here, guys, is I'm going to go over to the book. And let's see here. I'm looking at the positive values here. And I see 0.9484, 0.9495, 0.9505, but I don't have my 0.95. Well, I see a star here. I follow that star over. Yep, there's the 0.95 area. The z-score then is 1.645. And that is a rounded answer, but that's my z-score that I'm looking for, guys. So therefore my answer for this would be 1.645. If you plugged it into Excel, you would get 1.644853627, right? Because there's not as much rounding. But this is just a rounded answer and it works for us, okay? Now, except in special cases, if the z-score is midway between the scores, you select the largest value, okay? So the special cases are these ones that I'm showing you here. They're over here in this chart, right over here. These are the special cases. For all the other ones except for these ones, the book just wants you to choose the larger value. So if I were up here and I were looking for 0.95 and I couldn't find it, and I were in between these values, sorry, you're not seeing what I'm pointing at. Let me get to where I don't see 0.95 here and I don't see a special value, just pretend. Then I would choose the larger one, which is 0.9505. Okay? So that's what we're going to do when we have special cases. Now, if the z-score is greater than 3.49, we use 0.9999. Okay? And if it's less than negative 3.49, we're going to use 0.0001. Alright, so that's if it's less than or greater than 3.49 or less than negative 3.49, which is beyond the scope of the book here, right? You see it right here. 3.50 and up, you're going to use that. Okay? And over here on the left side for the negatives, negative 3.50 and lower, you use this value. Fair enough? Good. Now, this is going on for quite a while, isn't it, guys? I'm trying to hurry. Find the score that separates the bottom 2.5% and the top 2.5%. Alright, well, if I need to find the scores for those, what I need to do is this. Let me write down what this is asking us, okay? We want to find the scores that separate the bottom 2.5% and the top 2.5%. In other words, we're looking for 0.025 over here, which is the 2.5%, and 0.025 over here, which is the top 2.5%. Now guys, you're going to look for the z-scores on those, okay? You're going to look in your book. You're going to find, you're not looking at the z-score, you're looking at the probabilities, and you're going to match that up to the z-score. So when I'm looking here, I get negative 1.96 is the z-score here. Oops. And this is positive 1.96. They don't always match up, but sometimes they do. But anyway, that's my z-score for those, okay? Alright, now guys, just so you know how I found this top z-score, I'm not looking for 0.025 because 0.025 gave me this answer. I'm looking for everything above this, so it would have been 1 minus 0.025, and that would have given me 0.975. I would have been looking for 0.975 probability within the table to match it up with the z-score of 1.96 because it's everything greater than. That's the top hat. That's the top 2.5%. Okay? Alright, critical values. A critical value is a z-score separating unlikely values from those that are likely. So it's denoted like this. Here's how we denote z-score. Z, and then we have this little fish type thing. That's alpha. It's a Greek symbol, alpha. And this denotes the z-score with an area of alpha. A z-score with an area of alpha. Remember, the area is the same as the probability. Okay. To its right. To its right. Alright, so if we want to find z of 0.025, well, that means a z-score with an area of 0.025 to its right. Well, we already found that before. If I'm looking at my curve, this was the 0.025, this was the 0.025 to the right. You'll remember that this was 1 minus 0.025, and I found that z-score is 1.96. So the answer here, my z-score is 1.96. And that's how that works. That's what that means. You're finding that area for everything to the right of it. So this one is the area to the left. This is the one that denotes the area to the right. Okay, if it says to the right, you're always going to do 1 minus that value to find out the probability that you need, which was 0.975, remember? And then that helped me find my z-score. Okay, that's it.